So this video is for problem number 5 on the review for test number 2 for statics. And this is a distributed loading problem where we're trying to find an equivalent resultant force and find its location on the beam, much like we did in the last problem. So the first thing I'm going to do is separate my distributed load into pieces that I can analyze. So I'm going to take this first triangle, I'm going to outline it in blue, so that we know that's going to be our blue triangle. That's going to be our number 1 force. So I'll say number 1. And then we're going to have, in purple, we're going to have this other distributed loading, which is in the shape of a rectangle. And that's going to be area number 2. So the first thing I'm going to do is calculate the magnitude of the forces that these distributed loadings cause so that I can figure out how much they are and where they act on the beam. So for number 1, the resultant force for number 1 is going to be the area of the triangle, which is 1/2 times its base, which is 3 meters, times its height, which is 2 kilonewtons per meter, which is going to give me, because that's 4 minus 2, that's why that's 2, in case you were wondering. It's 4 total, but then it's 2 that's part of our rectangle. So that's going to give me a total of 3 kilonewtons. And it is going to act away from A. It's going to be, its distance is going to be the 3 plus 2/3 of the other 3 is where it's going to act. And that is going to put me somewhere around 5 meters. And then for part 2 of the distributed loading, FR2 is a rectangle, so it's going to be the base times the height, which is 6 meters. Its height is 2 kilonewtons per meter, so that's going to equal 12 kilonewtons. And it is going to act in the center, so its X bar is going to be half of the full beam, which is 6, which is going to be acting at 3 meters. So now I'm going to put that on a free body diagram so we kind of understand everything that we've brought in. So somewhere around here, we're going to have this 3 kilonewton per meter force, 3 kilonewton force. And then we are going to have the 12 kilonewton force somewhere around the middle, kind of like about here. So that's going to be our 12 kilonewton. And we've got our point A over here on the left. So if I was to take my measurements now, so that this can be the free body diagram for my analysis, I am going to have 2 different lengths. I'm going to have one up to the 12 kilonewtons, which I calculated is 3 meters, and one to the 3 kilonewtons, which is going to be 5 meters. So now I can analyze fully what I've got. So my resultant force is going to be in the downward direction. So it is going to be 12 plus 3, which equals 15 kilonewtons, and it's down. So if I calculate the moments about point A, because now I want to find the distance where the resultant force will act. So I've got the resultant force, it goes straight down, so there's no direction. I am going to take the moments about point A. I'm going to say counterclockwise is positive. The moments about point A are going to be the 12 kilonewton negative 12, because it's going to go clockwise, times a distance of 3. And I've also got a negative 3, because it's going to go clockwise, times 5, which equals negative 51 kilonewton dot meters. And so when I go to solve to find my distance that my two forces are going to act, I am going to say we are only using the downward component, which is all we have in this case. So my resultant force is 15 kilonewtons. And so down here on my beam, if I was drawing my force, my resultant force for my answer, I would have my resultant force equals 15 kilonewtons down. And then what I'm solving for right now is this distance. Whoa, that didn't go right. It doesn't want to do it right, so we're just going to call it good. I need to solve for this distance. So to do that, I'm going to take my 15 kilonewton force. And remember, I'm looking at point A over here. So my moment's about point A. For the resultant force, it's going to be 15. It's negative, causing it to go down. So it's negative 15. And the distance is whatever that D is that we're trying to calculate. We're going to set that equal to the negative 51. And I'm going to solve for D. And D equals 3.4 meters. So that is my answer, 3.4 meters. All right, study hard. Good luck.